So remember, we have 3 steps that the third line goes through. You have antigen challenge. You have all these different receptors that you inherited from your parents. Pathogens each have a unique antigen. And you have to go through and find your receptor that matches the antigen of the pathogen that is making you sick right now. This can take several days because it's just trial and error. Once you find your match, you do clonal selection. Now you have to make a whole army of these lymphocytes that match. Once you have your army, you are ready for effector response. Effector response is where you now fight the pathogen and then you get better. You already know antigen challenge and clonal selection, so now we can look at effector response. First, we'll look at helper T. So remember, helper T secretes interleukin, and this causes cells to clone. So the effector response of helper T is to cause the cloning by secreting interleukin. Then we have cytotoxic T. Cytotoxic T interacts with body cells. Remember, an infected cell will display pathogen antigen. And if the pathogen antigen matches the TCR on that cytotoxic T, then it kills that infected body cell. Remember that infected cells are doomed. You can't save an infected cell, so your goal becomes to stop the spread of infection. Here's how the cytotoxic T kills. It secretes perforin and gramzyme. Perforin and gramzyme cause the cell to die by apoptosis. The cell shrivels up and traps the infection inside. This way you stop the spread of the infection. So you get rid of an infected cell and you stop the infection from spreading. Then the B cells, remember the B cells clone into plasma cells. And plasma cells make antibody. So here is antibody. And this antibody fits the pathogen antigen. So it's not just any antibody. It's antibody specific to the pathogen you are sick with right now. And another note is that all 3 of these leave behind memory cells. So once the infection is over, you will keep part of that army that you built up. That's how immunity works. You go through all the trouble to do antigen challenge, find the one that matches, you do clonal selection, you build up a whole army. Then after the infection is over, you keep some of that army. Then if this same infection comes back, you're ready to go. Okay, let's continue on with effector response and look at what antibodies do. So we said that B cells clone into plasma cells, which make antibodies. There are 6 things that antibodies do. The first one is neutralization. Here is your pathogen, and all these Y-shaped things are antibodies. Notice the antibodies are coating the pathogen. Remember, antibodies fit the pathogen antigen. So the antibody coats the pathogen. And now the pathogen is all bogged down in these antibodies clinging to it, and it can't do anything. So the pathogen becomes useless. It can't harm you while it's coated in antibodies. So you've neutralized the pathogen. The next one is agglutination. You should already know what this is because we talked about it in chapter 18 with red blood cells. If you get blood cells that don't match you, you'll have agglutination. It's the same thing. Remember then we talked about an antibody would bind 2 red blood cells and you would get clumps? Well, now you're just getting clumps of pathogen. So this is where one antibody will bind 2 pathogens. And then see how it goes around. So this one is binding 2, and then this one is also bound to there, and it goes around, and again, you form a clump. And just like with neutralization, the pathogens can't harm you now because they're trapped in this clump. The third one is precipitation. It's just like agglutination. The only difference is that now it's a toxin rather than a pathogen. So this is where one antibody binds 2 toxins, and you form clumps. This would be how your body responds like to a snake bite or a sting from a bee or another insect. Some bacteria produce toxins. So if the toxins are trapped in a clump, they can't hurt you. The next one, next couple of them actually are going to be familiar to you. This one is complement fixation. Remember back when we were learning the second line and learning about complement? Here it is again. You would have that red blood cell here. Here's your pathogen. Here's the antibody. Here's the complement. This is where you hitch a ride on a red blood cell to deliver the pathogen to the liver. And then when you get there, macrophages in the liver destroy the pathogen. The next one is opsonization. We also talked about this in the second line because complement does this too. This is the one that I said is like ketchup. Complement and antibody both have the ability to coat the pathogen, and that attracts a macrophage. Remember, macrophages basically eat the pathogen. So it's like putting ketchup on food so that you'll eat the food. The third one here, or I'm sorry, the last one, the sixth one, is the activation of natural killer cells. Here is the natural killer cell. Remember before we talked about these with the interferon, that interferon will attract a natural killer cell. Well, antibodies are the other thing that attracts a natural killer cell. So here is an infected body cell. Antibody will stick to an infected body cell. Remember, infected body cells will display pathogen antigen. And your antibody matches pathogen antigen. So the antibody will bind to the pathogen antigen displayed on an infected cell. Natural killer cells see these antibodies attached to the infected cell, and they know that that's an infected cell that they should kill. So this is a signal to the natural killer cell, and it will secrete perforin and granzyme, and you'll get apoptosis, which, remember, traps the infection inside. A little more information about antibodies is the types. There are 5 classes of antibodies. Okay, and notice it says Ig. Ig stands for immunoglobulin. This just means it's a protein of the immune system. So that's what an antibody is. It's a protein of immunity. So it's an immunoglobulin. So that's why these say IgA, IgD, and so on. These are the classes of antibody. IgA is found in external fluids. This would be things like tears. There's IgA in your tears protecting your eyes, in saliva, and in breast milk. So this is how mothers protect their babies. IgD is the BCR on B cells. IgE is used to fight parasites. It is also implicated in allergies. If you're having a lot of allergies, you're going to have high levels of IgE. The IgG is in internal fluid. Such as blood and cerebrospinal fluid. IgM is also in your blood, and this is the one that causes agglutination. So when we were testing blood types back in chapter 18, that was IgM antibody we were using to look for agglutination. Okay. The last topic we're going to go over in this video now is primary and secondary response and active and passive immunity. So this is just kind of putting it all together and looking at the big picture here. Remember we said that you keep back memory cells. You do antigen challenge, you do clonal selection, you build up an army. Then when the infection's over, you keep some of that part of that army as your memory cells. So a primary response is the first encounter with that pathogen. Okay, this is when you get sick. This is a brand new pathogen to your body. Your immune system has to go through the 3 steps. So you have to do antigen challenge and clonal selection. Remember, this takes days. This could take about a week to do. So during that week, you're sick because your 3rd line is not up and running yet. But remember, once you do this, you make memory cells. So then a secondary response is when you have an encounter with that same pathogen again. You don't get sick again because this time you already have your army. Your memory cells are ready to fight immediately. And they destroy the pathogen before you get sick. Okay, so notice it says that the secondary response is faster because you have your army ready to go. And also it says that it is larger, because every time you encounter that pathogen, you increase the number of memory cells you have. So you again make memory cells. So every time you encounter a pathogen, you increase the size of your army against that pathogen. So the more you're exposed to a pathogen, the more immune to it you become. You might also be thinking that like you've had the flu several times or you've had a cold several times. You won't get the same flu or the same cold again because you become immune to a particular pathogen. But with things like cold and flu and pneumonia, there's several different pathogens that can cause that infection. That's why you can get the flu every year, because there are so many pathogens that cause it and they mutate very quickly. So your body will learn to be immune to one, but then if it mutates, you're not immune to the new mutation of it. Okay, now we can look at active and passive immunity and natural and artificial. We'll just go through these. We'll start with natural active. This is when you get sick, you make memory cells, and you are now immune to that pathogen. Okay, so this is basically what we just talked about. A pathogen makes you sick, you do antigen challenge, clonal selection, you get memory cells. Then if that same pathogen comes back, your memory cells are ready to destroy it right away. Then we have natural passive. This is mother to child. A baby is born with their mom's antibodies. Now, this is only temporary. It'll last about 6 months. Antibodies don't last forever. They wear out and you lose them. But for the first 6 months, the baby has the mother's antibodies protecting them. Now, if the mother breastfeeds, then that lasts longer because there are also antibodies in breast milk. So as long as a baby is being breastfed, that baby will have natural passive immunity. The next one is artificial active. This is vaccines. When you get a vaccine, you are injected with a dead or weakened pathogen. Because the pathogen is dead or weakened, it does not cause disease. But your B cells and T cells don't know that the pathogen is dead. They just respond to the antigen on it. So you will do antigen challenge and clonal selection. And you will get memory cells. So now, if you ever do encounter the real pathogen, you already have an army ready to fight it. So you get the memory cells, but you don't have to suffer through having the disease in order to get those memory cells. And the last one is artificial passive. Okay, just like with natural passive, you're getting antibodies. In natural passive, the antibodies are naturally passed from mother to child. In this one, you also get someone else's antibodies. This is typically done with horses, or traditionally done with horses. And this is an example of how antivenom is made. So, for example, you can inject snake venom into a horse. Okay, remember before in chapter 16 we were talking about vegetables and toxins, and we said the dose makes the poison? You're not killing the horse. Horses are really big and they can handle it. So you're injecting some venom in there, but the horse is fine. And the horse will make antibodies. You then extract these antibodies from the horse's blood, and when somebody gets bit by a snake, you give them those antibodies, and it saves them from the poisonous snake bite. Another example of this is to treat Ebola. You may remember a few years ago there was a big Ebola outbreak. There is no vaccine nor cure for Ebola. It's a very dangerous virus. There's not much we can do about it. But the one thing that we can do is get antibodies from Ebola survivors. So even though a lot of people who catch Ebola die from it, there are a few people who have had Ebola and survived. So those few people who have had it and survived have memory cells, and they can make antibodies. So a few years ago, when there were the Ebola outbreaks and people were coming down sick with it, there were survivors who were donating their blood so that we could get the antibodies from their blood and use to treat the people who are currently sick. It's not a perfect situation. Some of the people who received the treatment did still die, but it does increase the odds of survival. All right, so that is it for chapter 22 for now. Everything else we will talk about in class.